Well, good afternoon, everyone. Thank you for standing by. Welcome to the Innovations in Energy Resilience. My name is Emmett Owens, and I represent the Research Triangle Cleantech Cluster. I want to begin by thanking you all for joining us. I know this conversation focused on energy resilience will be especially important for utilities, municipalities, and those involved in the renewable energy sector. I especially want to thank Cisco and for their technology to host this webinar. They are one of our key investors and our key board members, and their leadership in energy and related industries cannot be overstated. I also want to thank the Southeast Energy News for their sponsorship and helping to get this out on a regional and national level. Every morning, thousands of readers turn to Southeast Energy News for the latest developments from around the region. You can sign up free today at energynews.us/southeast, and you can see that URL there on the screen. Before we get too far into today's event, I want to take a few moments to go over some housekeeping items. One of those things is attendees need to be in listen-only mode, so if you're not on mute, make sure you're on mute. You should have been on mute when you got in. And as a head recording this event to share with others, so those two things should be of note. And we're really excited about today as well. For those of you who have attended RTCC events in the past, you know we really enjoy facilitating networking and connections. And so today is our first foray into virtual networking. And so, you know, I hope you all are able to take advantage and leverage the chat feature of WebEx to facilitate the networking amongst each other. We encourage each of you and hope you can make a valuable connection. Those interested in virtual networking received an email from me yesterday afternoon, and you should have received with the names and organizational affiliation of those who are participating. Out of the respects for the participants and presenters, we ask that you please privately message, don't group message everyone unless it's relevant, and message in order to connect with each other. You can find the chat feature if you see on my screen. Depending on if you have the upper right corner, you can see all the different modes. You can look at your screen, but you should be able to see in either case on the bottom of your screen the chat box. If you click that icon, you'll be able to see chat appear on your right side of your screen, and you can just select the drop-down list to privately chat with whomever you're interested in connecting with. We also, as you can see there, take a few minutes to talk about our Q&A. So if you have any Q&A you want to have, please just private message me and I'll shoot it to Ken, and he can figure out if he wants to use that question or not. So again, private message me with any questions you have for the panelists during the event, and I will make sure Ken gets them. And so now I'm going to kind of do a little bit of housekeeping, a queue of sorts. Before I turn it over to Ken, I'm going to discuss the Research Triangle Cleantech Cluster and who we are and what we do. We're a membership-driven nonprofit focused on accelerating the growth of clean tech in the Research Triangle region in North Carolina. Without our members, as you can see on this slide, so we really appreciate their support, and hope if you see a few folks that pique your interest, have a chance to check them out. We're also part of the North Carolina Clean Tech Corridor, and so with our partners, Jules Accelerator down in Charlotte. And so this is a 3-year grant that's focused on creating greater deployment of clean tech between the Charlotte and Raleigh areas. So I encourage you to check out that website at nccleantechcorridor.org to learn more. And with that, I think I'm going to turn it over to Ken, who is over at the FREEDM System Center. So I'll let Ken take it from here.
Okay. Ken had to remember to unmute his microphone. I hope everybody's doing well today, and obviously staying safe if we're all indoors on a webinar. It is a beautiful day outside here in North Carolina, so for those of you locally, I recommend taking a break after this webinar. Emmett, next slide. I'm going to talk a little bit about the FREEDM Center. I think. There we go. Okay. Thank you. Yeah, so FREEDM, for those of you that don't know, FREEDM stands for Future Renewable Electric Energy Delivery and Management System Center. We are an engineering research center headquartered at NC State. Our focus is on power electronics and power systems. Our initial project plan and vision for the center involved essentially a network of distributed energy resources um, could integrate more distributed energy into the grid. There's a whole systems approach. You've got software layers, you've got power electronics that go in with that. And that was 10 years ago, you know, when there was not a whole lot of solar on the grid, prices were coming down, but we saw ahead to when prices were going to drop and there was going to be a lot more renewable energy that needed a system to appropriately manage that. So that's where a lot of our research went, was to develop that system. And in the images here, you can see our lab, right? We've got a high bay lab space that has a lot of cool toys. We've also got 40 kilowatts of solar on our roof that's integrated into that. So FREEDM really is a powerhouse at NC State for researching things like microgrids, like distributed energy resources, like the kinds of things we're going to talk about today. We have about a dozen faculty affiliated with the center, 80 to 100 graduate students that are all working towards this goal in a bunch of different aspects. On the right-hand side of this slide there, you can see the way that we identify ourselves now is we have 4 research pillars. Wide bandgap power electronics, that's what WBG stands for, are really new. I'm going to call it new. They've been around for a while, but we're finding new applications for these varieties of power electronics, which are silicon carbide and gallium nitride devices. It's really opened up entirely new ways to build power electronics that are more powerful, more power dense, and more efficient than what we've had before. So that's kind of the fundamental of a lot of the other applications that we do. Those things include electric transportation. We build highly efficient motors. We design new electric vehicle chargers. We still do the traditional power systems research that utilities like Duke Energy, Florida Power and Light, New York Power Authority all still require to operate their systems. And then we also look at microgrids and renewable energy integration, again, as a part of our research. So next slide. But what I'm going to do now is I'm going to just use a little bit of trivia to introduce some of the other research things around NC State and relate those to some of the things that that we do at the FREEDM Center. I had warned our panelists about this beforehand, but Tony, who is the gentleman in the top left in the dapper suit and tie?
It looks like you might be a dean of something.
Oh, very close. That's actually Jim Good, who is the CEO of SAS. SAS is actually a startup out of NC State, along with another small company you may have heard of. Cree is another startup out of NC State. Every year, NC State generates a lot of startups. We have over 170 that have attracted 170 startups that have attracted over $1.6 billion in venture capital. NC State's actually listed as #2 nationwide in licensing of our inventions for schools without a medical school. Med school budgets kind of throw everything off. Okay, so Kevin, you get the next question. Who is the lady in the blue shirt there?
Well, other than the fact that she's clearly in a zero gravity environment, I don't know, but I think that kind of limits the options there.
You guys are letting me down. That's okay. That is Christina Cook. Christina is an astronaut, obviously. She just got back from a long stint at the International Space Station. She is a graduate of the electrical engineering program at NC State, which, NC State is one of the largest electrical engineering departments in the country. We produce over 400 graduates every year. We're like in the top 5 in the US for EE degrees. But within that Department of Electrical Engineering, we host 2 engineering research centers. So there's FREEDM, and then there's one ASSIST that focuses on self-powered health monitoring devices. They are very busy these days. And then we also have the Center for Manufacturing Innovation that is called Power America, which again focuses on development of those wide bandgap semiconductor materials that I talked about. So Mark, I know that you're remote and not sure if you can actually see the screen, but if you can, do you know who the lady is there in the bright orange shirt?
I wish I did.
You wish you did, but you can't. You don't know. Okay, that is actually Vivian Howard. She is an NC State graduate. If anybody knows the TV show Chef Life, or Chef Life, I think is the name of the show. Her restaurant is in Kinston, Chef and the Farmer. But this is related in kind of a roundabout way. I didn't really have any other famous alumni related to food service, but NC State also has a lot of our, the inventions that we disclose and the things we come up with lead to royalties that come back to the university. And Emmett, this is actually a question for you. What is the largest grossing patent from NC State?
Oh man, I'm sure it's to do with power electronics or smart grid.
Vivian Howard is the clue. It has to do with food. Remember, NC State.
Really?
We're a big ag school, man. And actually, I emailed our guys in research commercialization earlier. It actually comes from a liquid egg technology in the 1980s. It's all about pasteurizing eggs for a liquid egg product. And the second is also related to food. It's a thing that keeps fresh fruits and vegetables fresher longer. It's an ethylene inhibitor. Anyway, little bits of trivia. And I'm not going to ask you guys who that person is in the lower right corner, unless you know. Any of the panelists know? He's very famous in power electronics circles.
That's right. Dr. Balaga invented the IGBT, kind of the heart of every power converter that we'd be talking about today.
Tony, you have totally redeemed yourself.
That's right.
Yes, Jay Balaga is on staff at NC State, and he is a member of the FREEDM Center, one of our faculty that helps us develop these new silicon carbide devices. He is the inventor of the IGBT, the insulated gate bipolar transistor, which is like Tony said, the foundation of a lot of power electronics that are enabling us to do some of the things with distributed energy resources and microgrids that we do today. Okay, next slide. That was just trivia, something fun to talk about on a Friday afternoon. We're now going to focus on resilience. Which, if I can get to notes, resilience. So one of the things about resilience is that it does require a systems approach, right? If you're a town or a municipality or a building manager, you have to think, okay, if I'm going to be resilient to whatever happens, whether it's a power outage, whether it's flooding, whether it's a hurricane that may have both of those things together, you can't simply look at just electricity or just how my workers going to get to work, how's my staff going to come into the office, that kind of thing. You do have to look at it from a systems approach. However, electricity, as they say, electricity is a 5% of the total economy, but it is the first 5%. So it's one of those fundamental things that you have to get right if you start looking at, in general, at resiliency. It also requires community planning. You can't just think about resiliency for just your business or just your particular area of focus. You have to look broader and include other stakeholders as part of that. Another piece is you have to consider what is the value of the investment that we may have to make. What's that value of resiliency? I can tell you that within the microgrid industry and within distributed energy resource industry, that has been a big debate. Exactly how do you come up with a value for resiliency? And there's not a clear definition because it's very much specific to exactly what your operations may be. What things would you miss as part of that? What's the cost that incurs because of those things? But if you're going to look at electricity, if you're going to consider all of these different things, you really should engage your electric utility. I had brief discussions earlier this week with both the co-ops and representatives from Duke Energy and Electricities on, how they engage with some of their customers. All of them are looking at certainly ways to make the grid itself, the grid writ large, much more resilient, but also looking at ways that they can help individual customers improve their resilience as well. One of the documents that several of them mentioned was the one that's shown here. This is from the cover page. It's the Energy Resilience Assessment Methodology from the National Renewable Energy Lab. That is a free document that's available. You can just go on the website or Google this and get more details and download that. It is a good read. It's more of a checklist of all the things that you may need to consider when you evaluate resiliency and evaluate the needs for your facility. But I do recommend that. And the utilities that I've talked to were said that it was also a very good document, one of the better ones that they had found. So just to, that's, big picture overview. Freedom's doing really cool research. NC State is a great university. Let's focus now on resilience and some of the other tools that are out there. So I want to introduce you guys to our panelists today, and I'm going to do very brief introductions, just let them talk a little bit more about their particular and we're going to start with Kevin Marr. Kevin is the president of Power Analytics. He will certainly get into details about what they do and what they offer. Mark Martak is the chief sales officer for Power Secure, which also here in the Raleigh area. And then Tony Olivo is the vice president for engineering at FlexGen, another company involved in microgrids and distributed energy resources here in the Trine. So the way that we're going to do the presentations, we're going to let Tony go first. So Tony, these are your slides, and I will be quiet and let you talk.
Great. Thank you, Ken. And FlexGen, we are an energy storage integration company headquartered in Durham, North Carolina. And we've been involved in lithium-ion batteries, renewables, thermal generation like diesel and natural gas gensets, building microgrids and utility scale solutions for the last 8 years. Myself, I've been in power conversion and energy storage for the last 12 years. And I've gotten to see many megawatts and megawatt hours installed over the years. So I want to start by talking a little bit about our normal or our historic view on resiliency. In the last few years, most of the conversations around resiliency have been in the wake of Hurricane Sandy and Maria and Harvey. There are procurement initiatives out of New York, Massachusetts, to specifically address resiliency when there is a natural disaster and a loss of infrastructure. Compared to hurricanes and earthquakes and tornadoes, COVID-19 and other pandemics really don't have a high chance of destroying our infrastructure in the way that we've been thinking about resilience in the past. However, the changes to how we all act, the fact that we are all home, that plants, processing plants and manufacturing plants get shut down because there are not people to man them, cause changes in the electrical network that we would not be expecting. Obviously, there are a lot of changes across different areas. On the picture on the right shows nitrous oxide emissions in the Los Angeles metro area, 2020 versus 2019, and just that there are just that loss of transportation, that nobody's driving around in Los Angeles, has greatly improved their air quality. It's lowering the amount of greenhouse gases being emitted. There is a measurable change in the seismological background noise for people measuring earthquakes. So there are a lot of surprising effects coming out of our recent changes in COVID-19 environment. Next slide, please. So what in particular I want to highlight is that in the last about 40 to 45 days, US production of electricity, coal has fallen below the total generation provided by renewables, meaning solar, wind, and hydro, for the longest duration in our history. So what we expect then is that as we expect that this is a result of lower overall demand, and coal in particular has been struggling from a market economic perspective, that it's relatively expensive to operate coal plants compared to renewables, especially, so that they would be the first to be shut down. And we see that trend already taking place. Many gigawatts of coal plants being shut down across. The most recent ones I've seen are Montana, Idaho, and Indiana, that some very large coal plants have been coming offline. The physics of that is that the large turbines that coal-fired plants generate electricity with, they are a means of energy storage for the grid. They add this inertia, which stabilizes the frequency and basically keeps our lights from flickering. As those rotating thermal power plants get shut down, you then are looking at renewables. Solar especially, there's really no physical mass spinning around, there's not really any energy stored. A cloud goes overhead and that's it. No more power is produced by the solar field. So what we're going to get a sort of look into the future here, due to COVID-19 and the lowered energy demand in general, is we're going to get a look ahead to that future where coal plants and even natural gas plants keep going offline, and the percentage of renewables on the grid go up, and we're going to start seeing stability issues on the grid because of those changes in demand and the changes in production, since renewables are by nature intermittent sources. There are a few solutions to that, and I'll talk about that in the next slide, that FlexGen in particular works on. So we have, on the left, been deploying hybrid battery storage power plants for a number of years, from small microgrids in the 3 kilowatt range to large utility scale systems up to 300 megawatts. We mix in these cases the batteries with solar, wind, or thermal generation, natural gas peakers or diesel backup generators. And what we can do with those is provide these synthetic inertia services for the grid. Basically, in place of that giant spinning piece of steel that's part of a gas or a coal plant, we can replace that with intelligent electronic controls that are connected to the battery, and using the very large energy capacity of lithium-ion batteries to provide those inertia services. And this is actually something that some utilities and independent service operators have gotten familiar with and have put requirements on new power plants being generated, being constructed. California and Hawaii in particular require certain standards of solar inverters going into their distribution grids, and that is a part of the solution. And there are energy storage can be a big part of that as you get into larger utility scale. And of course, when you have batteries and you have this mix of assets, you have the more traditional sense of resiliency provided by microgrids, which I know my co-presenters are going to speak more on in terms of islanding and getting to the other areas. On the right-hand side, I just want to touch on that briefly. A little more like the traditional resilience, that batteries can be used as a black start energy source. So in the case where infrastructure is damaged and part of the grid is lost, often large power plants expect there to be some kind of power available to say start a pump or a starter motor, just like in your car, to be able to kind of kickstart the operation of a large power plant. Batteries, lithium-ion batteries, and the plants that FlexGen works on can supply that, as well as providing all of the grid reliability and stability services that we talked about on the left-hand side. So that's another important area when there are large plants coming offline, what sort of springs up in their place. So I'll turn it back over to you, Ken. Thank you.
Okay, great. Thank you, Tony. Yeah, so battery storage is a great solution for a lot of the, like you said, the issues that the grid may be facing as we get more renewables. Stability is an issue, and of course, the black start capability is also very important. So next, we're going to hear from Mark at PowerSecure. So Mark, make sure you unmute.
Yeah, Ken, can you hear me?
Yes, we can. Go ahead.
Okay, sorry about that. Hey, sorry about earlier. You asked me the question, and my chin hit my phone when I took it off of mute, and I hung up on you right when I was going to say I wish I did know who that young lady was, but I didn't. But anyway, hey, it's a pleasure to be here. Sorry, everybody. I am quite remote today. That's why I'm having a little bit of difficulty here. But yeah, I am Mark Martek. I'm the Chief Sales Officer of PowerSecure. And PowerSecure has 2.5 gigawatts of active microgrids across the United States. Those microgrids are located on 1,400 plus mission critical customer sites and behind over 250 utilities. And I'm going to echo some of what Tony said. In my 20 years at PowerSecure and then a previous 20 years in the mission critical power business, I have never seen a paradigm shift occur so quickly as it has with our customers when it comes to their views on how they define true resiliency. And Tony hit on some of this, but before the virus, customers viewed resiliency from the perspective that they had to cover an event that was rare, relatively low probability, usually geographically contained, and a relatively short term. When you think about hurricanes, tropical storms, tornadoes, and most recently fires. And they kind of did what they needed to do to just kind of muscle through that event because, again, they were rare and relatively short term. Now, CV-19 has changed all that, and it's changed it very, very quickly. The paradigm has shifted from a view on the need for resiliency from a rare, low probability event to kind of an unknown probability, and from a geographically contained event to one that could have unlimited geography, and from a short-term event that could be much longer term, as we are all seeing and experiencing. And this paradigm shift has resulted into a laser focus in how they're going to invest their money, and their first choice is going to be true resiliency. Now, if you couple that with the fact that their bottom lines have taken a big hit here, and there's going to be a lot of internal competition within companies for more limited financial resources, especially in the short term, and those financial resources, resiliency, like we're here concerned today about energy resiliency, but depending on the customer, there's multiple facets of what resiliency means to them. Energy is obviously an important one, but it's not the only one. So as we see it, there's a big challenge here for us that are concerned about clean energy, that we need to provide energy system resiliency solutions that at the same time enhance environmental sustainability, and then also have either an attractive rate of return, or we come up with creative financial terms to help our customers conserve cash in the short term. Next slide. So we believe microgrids can offer that, offer extraordinary value versus traditional approaches to energy resiliency. At PowerSecure, we first create and then we design and build and operate microgrids based on what we call a total value proposition to both our mission critical customers and the utilities that serve them. Now, customers are going to place an inherent value on resiliency, based on business continuity, loss prevention, et cetera. And some of our customers are very, very sophisticated when it comes to being able to put numbers to this. But we more often see is that the value to them is derived from some budget constraint. It could come down from management. It could be, hey, this is what we need resiliency, but this is what we can afford, kind of a thing. Utilities will oftentimes have value for those same energy assets. And that value can be derived from a number of different items. And Tony hit on this, and really interesting. So this first thing, a non-spinning substitute for spinning reserve. Utilities have anywhere between 10 to 15% spinning reserves that run 24/7 all the time, and that costs money, and it also has an impact on the environment. So these microgrids can serve as a non-spinning substitute for those spinning reserves. And what Tony was talking about, as the renewable portfolios are increased, that places even more demand on these kind of clean non-spinning substitutes for spinning reserve. And if you don't believe me, just Google Germany's energy woes, and you'll see what's happened there. They touted for years and years a very high solar portfolio, which was wonderful, but they're firming it with coal. And now they've spent trillions and trillions of euros, and their environment is actually dirtier than it used to be. So, and you can read all this. If you don't believe me, just read it. Other utility values, it's demand response, peak load management, frequency control, duct curve mitigation. It's those issues that Tony was talking about that, when you get renewables and, what happens on the hottest afternoon when the sun goes behind a cloud, or on the hottest afternoon when the wind's not blowing. Usually that's when you'd have your hottest afternoon. So there's value to the utilities in maintaining a stable grid, obviously. And then in high load pockets, oftentimes the utilities can put in these microgrids at customer sites where we can, and they can be used to offset capital that would be needed for transmission and distribution kind of upgrades. So when a mission critical customer's needs and a utility needs can be served by the same shared microgrid, that's when the magic really happens. And oftentimes it is through hybrid microgrids that have multiple sources and much cleaner sources than may be available on the grid. And I've listed a few here. There's a lot of exciting technologies out there. Now what I'd like to do is give you guys some practical examples of what I'm talking about. So next slide, please. So in Yuma, Arizona, we provided a 25 megawatt microgrid at the Marine Corps Air Station that provides 100% clean EPA Tier 4 final generation resiliency to the base. But it also provides autonomous frequency control on the California ISO, which probably has more duct curve events and more intermittent renewable frequency issues than any other in our country. And the value to the utility with the autonomous frequency control, they were able to avoid those T&D upgrades that I talked about and other peak load management. They were actually able to provide this to the Marine Corps at zero capital dollars. That means we as taxpayers here in the United States paid zero to have that very important base 100% resilient. And phase 2 is just getting underway now, where we're going to be adding 25 megawatts hours of battery energy storage and 5.6 megawatts of solar to this system to add the sustainability piece to fully round it out. The next example I like to give, so we're an example of it today, right? So we're all working from home, and there's going to be, I think, more commerce happening with people working from home. So we have a need for our neighborhoods to become more resilient. We did a project in Alabama. It's called the Neighborhood of the Future. So we provided 100% resiliency to all the houses with a 400 kW natural gas generation, but also we provided 230 kW of solar and 825 kWh of energy storage batteries provide virtual uninterruptible power to that neighborhood in a very clean way. Versus if you think about, like with the California fires, what we heard is, people went to Home Depot and everything. They bought, small gas generators, diesel generators, etc. This is a way you can back up an entire neighborhood in a very clean and responsible way. Third example here is a hospital in Pennsylvania that was about to embark on an $8.5 million traditional upgrade to their standby power system. We're able to come in and do 7.5 megawatts of EPA Tier 4 final, very clean generation with N+4 redundancy, and we save them $3 million a year. In addition to that, it generates annual value of about $600,000 on the demand response program, which helps PJM avoid the spending reserve that I talked about earlier. Next example, we're starting design of a 25 megawatt microgrid at a pharmaceutical company in the Northeast. And this one's very special. It has a 25 megawatt bi-directional battery energy storage system. And this pharmaceutical campus had a need for uninterruptible power. And here's an example where the utility has a need for grid stability, and the customer had a need for a UPS basically to back them up, and the same battery energy storage system could accomplish both purposes. Not only that, we were able to gain direct access to the New England ISO, and we were able to drive the cost down to less than 5 cents per kilowatt hour in the Northeast. And another benefit of that was, if you're familiar with the Connecticut natural gas system, it's the most constricted natural gas system in the United States. They have a pretty high risk for natural gas curtailments in the wintertime, especially during polar vortexes. So now they have a 2N boiler, and of natural gas and of electricity, and they're able to totally mitigate that natural gas risk as well. And then the final example, this is out in California. We were very instrumental in a microgrid that includes 14 megawatts of PV, 5.4 megawatt hours of battery, 4 megawatts of fuel cells, and 6 megawatts of our always ready clean generation, all in one hybrid microgrid that actually brings that facility off and on the grid multiple times a day and provides long-term off-grid operational capability for a very high level of resiliency. So I just close by saying, we're very proud to be able to help our mission-critical customers and their utility partners to stay on course with clean energy while we're providing that true resiliency need in this post-virus world that we're all involved in at the moment. And, thank you. I'll turn it back over.
All right. Thanks, Mark. Yeah, those are some great examples of installations. I may have recognized the image of that last facility, but I understand if you can't tell us who it is.
Exactly.
Okay. All right. Well, tell you what, Kevin, you're certainly not the least of our speakers, but you do get to go last. Tell us a little bit about Power Analytics.
I will, and thank you, Ken. I appreciate the opportunity to be cleanup hitter here, especially the way you and Tony and Mark had the pretty solid debates that are coming into this. So Power Analytics, just briefly, has been involved in this concept of what we now call microgrids from the very beginning in Washington, D.C. as part of the smart grid working groups, and over the years has been directly involved in a lot of the analysis and the science associated with engineering associated with both renewable generation and early microgrid designs. One of the things that we certainly talk about consistently is the ability to be pretty agnostic. I should mention first off that Power Analytics is a software company, not a hardware company. So we, in a sense, don't have specific solutions in mind. But we also, much like Mark was talking, began our world in the mission critical space, primarily with critical infrastructure like the FAA and data centers. So that's kind of our background when we think about resiliency. We think about it from the, as they say, the 7 or 9 nines levels of availability. What's interesting about that is that, if you can go to the next slide, from my perspective, is that one of the organizations we've worked with a lot in the past 7 or 8 months now is the Agile Fractal Grid. That is an effort underway in multiple parts of the world, but in particular to work on an approach to the growth and development and implementation of resiliency, in particular, that is scalable on multiple levels. And so we introduced the concept of a virtual UPS, and if you're not familiar with that term, that's a uninterruptible power supply. And the idea is that it is, in our experience, certainly mine, one of the most difficult things that customers tend to have trouble with is they just don't know how to get started with the microgrid. In particular, the smaller the organization, or those universities or utilities who have a deep background in energy and power, that's never been a concern. But on smaller scale, it's very difficult to know to get started. So we specifically focused on just one aspect of the architecture, which is resiliency. And a UPS, much like if you know it, if you have a UPS at home, is designed to provide a certain amount of power for a certain load for a certain period of time. That amount of power it provides is directly applicable to how much you're running on. So the idea is that providing power engineers who are not necessarily familiar with concepts around hybridized or specialized control technologies that tend to dominate the microgrid space right now, but have a way to define a platform that can be broken down to its smallest component, with the most important thing we are emphasizing being resiliency. And then the ability to cluster those resilient virtual UPSs or nanogrids together in order to form a larger microgrid, and also to participate in some of the other aspects and markets that both Mark and Tony were talking about. So it's a different approach. It certainly does not mean that it's certainly not the answer to all of them, but it's certainly a little bit different inside there. We do that via a process that we also introduced a year and a half ago called the Power Digital Twin. And that lets us simulate in real time the operation of these smaller nanogrids and provide methodology and the architecture from a software perspective to grow and interconnect those into larger grids using the analytics that come from our power analysis software that you see in the number 2 side there. That process for us led to 2 significant changes in the last 6 months. One was the introduction of not just real-time data into the process, but also what might be referred to more as data lakes. So that would be data that would directly contribute to trying to understand in the resiliency model how much risk you have based on the components that really are driving your resiliency strategy. So there's an ISO standard called 55,000 that really came out of the utility segment, and that really drives so much of that. And we then began bringing in other data sources, including the spread of wildfires, weather, other events. So for those of you who know me, know that I'm a sailor and have raced sailboats for a while. And I can tell you that, when you're racing a boat, one of the things that you care about in a sailboat is having just a few seconds of advance notice of a little puff of wind maybe, or even a bigger storm coming down the road, so that you can adjust accordingly. So if you think about this whole effort, that leads to ultimately, if you could go to the last slide for me, that leads in our case to how we've also, let me just, Ken, you move it up one more slide. Now back one. There we go. Anyway, one of the things that we began back in March was using the concept of the wildfires in California and how they were spreading and growing that might impact the critical infrastructure that would then impact your high resiliency nanogrids or microgrids, and began overlaying what you're seeing there is COVID-19 data from Johns Hopkins and IMHE. That also led us to use that same infrastructure to begin introducing, in our case, this integrated approach, including, believe it or not, COVID-19 testing. So last week, Friday, we completed first responder testing for a number of first responders in the city of Hoboken. We're about to embark on a much larger scale integration of all that. In fact, just as an aside, we're looking to do that in North Carolina, Raleigh in particular area in the beginning of June. So if you want to learn more about that and talk to me about it, I'd be happy to do that. But as odd as it seems, and you saw from the other 2 presentations, really there's one aspect of COVID-19 that is consistent with all the things that we're talking about. It's a shift, as both Matt and Tony said, in the paradigm of the impact on energy generation and usage, as well as other portions of the critical infrastructure that rely on power, like data communications, first responder networks, and just generally even hospitals. So it as unusual as it might seem to think of it as multiple places, it actually is connected up and down the scale. So we're pretty enthusiastic about the impact that a lot of these changes will have on the process. But starting again, remember with this nanogrid, the nanogrid training, by the way, that we're also be providing virtually is something that we're also looking to integrate into the Solar Power International plan in the fall. Whether that'll be on an event as it's been in the past in Las Vegas, or it'll end up being virtual, is yet to be determined. But certainly all part and parcel with that. So that's a relatively quick discussion about it. I think I left enough time for a whole bunch of Ken questions.
Yeah, we've got some time. I will admit that each of us went a little bit over our allotted time. So I think instead of going through some of the original questions that we had, we're going to skip and ask some of the ones that we've received from the audience. And just as a reminder, if anybody does have questions, you can send those directly to Emmett, who will then forward them on to me. Use the chat feature when you do that. But so one of the questions that we've had, and I think each of you may have touched on this a little bit, what military bases have certain requirements for energy resilience? What are some of the things and some of the technologies that you see military bases integrating into their microgrids, if that's what they're pursuing? And Kevin, since you're unmuted, we'll let you go first. And then if Tony and Mark have something to add, we'll let them chime in.
Okay. Yeah, I think since we've been involved in military microgrids, I've seen a lot of evolution in early Spiders projects to the work we did at the 3 Navy bases in San Diego, and most recently in Camp Pendleton. But they do vary. You know, it's a large location. They, in many cases, are hampered by the ability to generate power for a larger community. In San Diego's case, for example, it didn't make a whole lot of sense for them to have a completely capable isolation capability, because most of the support staff live in the city of San Diego. And with things like lift stations that wouldn't be powered by the city, the civilian population and even the off-base population would never be able to get there in an extended power outage. So it's a unique set of circumstances, but they do have both congressional and Department of Defense mandates to solve those problems. So there's no question that they're working harder at that, I think, than any other segment.
But again, it sounds like, I mean, even for the military bases, they don't start by assuming we've got to power the entire base. They look at it holistically, like you said. They look at even outside of the base boundary and wait a minute, the parts that we really need to provide power to are just these few critical facilities.
Yep, certainly hospitals, data centers, mission, all aspects of the warfighter mission.
Right, exactly. Mark, why don't you give us an example or talk a little bit about the military microgrid?
Yeah, so what we're seeing is a lot, again, hybrids, integrating battery energy storage, charged by solar, depending on where the location of the base is and what the utility need is. You know, on the California ISO, they have a tremendous need for frequency control for, 2 to 4 hour battery storage for, those end of the day, sun going down, gotta ramp up very quickly. We're seeing a lot of, those combined with clean natural gas and EPA Tier 4 final diesel generation to just form a complete system that not only provides that resiliency and energy sustainability for the military base, but also for, the grid as a whole. We've got numerous proposals out there with exactly I just described.
Okay. Yeah. So, Tony, if you don't mind, I may shift questions and ask you a different one here. What is the difference between a microgrid and just having a backup generator?
I think what you're really expecting from a microgrid is some of the kind of virtual UPS functions, the ability to have seamless transfers that your customers, that your process don't really notice that there's a difference. Because yeah, like I mentioned earlier, that with just a backup solution, you're really maybe just worried about the critical loads and you're shedding everything else. And I think there is an expectation with a microgrid that there's some autonomous control and integration with your process and your building automation system. Basically, just a little more smarts than the automatic transfer and backup.
Sure. Okay. Yeah. Good. So one of the questions that we have had from the audience, the panel addressed cybersecurity as part of a strategy for energy resiliency.
Yeah, I could speak to that a bit as well. There's a recent, I think as recently as last Friday, executive orders coming from the president's desk regarding the use of certain Chinese vendors, control equipment, video recording equipment, specifically when used in power plant generation. So there's a lot of activity in that area right now. We have FlexGen ourselves have always worked with an isolation strategy. Chinese vendors do exist and they do make good products, but to isolate that from areas, networks that can become a risk, either just taking them off the internet completely, isolating through equipment like Cisco firewalls and things like that, but also just reducing the scope of those control systems wherever possible. Really limited down to the very low level components that can't interact with the outside world.
So if there was a hack, that it would only impact, you try to minimize basically the attack surface.
That's right. If the worst they can do is turn off one battery out of an array of 1,000, then we've kind of done our job.
Sure. Okay. Yeah. And the executive order that you're referring to currently only applies to bulk power system infrastructure, right? So things like large transformers or, like you said, things that are used in power plants. And the rules for that have not been written, so it's not clear, but some of the things I've read is that the utility industry is kind of scrambling to sort of figure out, okay, what does this mean? What are some of the potential implications? There's a lot of concern about, switching vendors or exactly how to comply with the requirements. Yeah. Anybody else have a cybersecurity comment?
But hey, this is Mark. We remotely monitor all our 1,400 plus sites, and these are, mission critical customer sites from, military installations to hospitals, data centers, pharmaceutical, continuous flow processes, et cetera. And I can tell you we're, because of that, we're kind of on the front end of a lot of this, and there is a tremendous focus now on cybersecurity amongst all our utility customers, where 5 years ago it was a concern, but now there's on every project there's a complete study done. All the protocols are determined up front, and it's a major focus of a particular group within our company.
Just to add to that a little bit, I think the other part that we see a lot of is EMP related electromagnetic pulse, and some of that critical infrastructure and how from the microgrid control side, how certain aspects of that are protected, and that's also there's mention of that also in what you were referring to. And I'm sure you already know that.
And hey, I'll throw one more thing in here about that. Post pandemic here, we have our customers. It used to be in resiliency and especially cybersecurity, et cetera, that they were thinking about one particular event, whether it be a solar surge or a hurricane or whatever, or, an individual hack. But now they're thinking in terms of what if we do have a pandemic, CV-19 or worse, and it's also accompanied by these hosts of other things that could happen at that exact same time, and what the ramifications of that might be on their systems and for their processes.
So I was a little bit of a I don't know what the word is, but our internet went out here at the house the other day, and it was down, and I immediately jumped to, oh man, it's a Russian cyber attack that's taken down the entire internet. And no, it was just the Spectrum guys up the street were messing around in the box for some reason. But anyway, again, the impact of these multiple events can get you worried about these kind of things, right? I mean, and the point of I think a lot of these resiliency efforts are to, not to get you afraid of everything, but to, kind of plan at least for the worst, so that, you wind up with sort of the best result that you can at the time. I do think it's important, again, to, go back. Each of the descriptions that we heard from our panelists are, you start with planning. What are your critical assets? What are the critical needs that you need to meet? What are the systems that may interact? Will employees be able to get to your facility? Just like Kevin mentioned for the military base. If they're not there, then you don't need some of these other functions. Can they still access things remotely? How are those related to communication efforts? What if the internet goes down? Do you have a backup for that? There's all sorts of things, and these all also stem from general best practices in emergency planning. But I think the concepts behind resiliency are a little bit larger than just emergency planning. It's more of not just how do you keep people safe, but how do you also build up your infrastructure so that you're able to maintain operations and do the job that you need to do. Emmett, I'm looking at our time here. It's almost 2:00.
Yeah, and I really want to thank everybody. I apologize. We usually try to, for these kinds of panels, do an hour and 30 minutes, but try to be virtual. We're trying to put in an hour block. In any case, we really appreciate the panelists. So do a virtual clap if you could for the panelists. Thank them for their time and for their thought leadership. Also want to thank everybody for participating and joining us this afternoon. Feel free, if there's anything you need, to shoot me a message. I'm happy to try to connect and convene based off some of the conversations that we've had. So with that, I'm going to say goodbye and thank everyone for your time, and thank Ken and Kevin and Mark and Tony for their time. So thank you.
Thank you, Emmett.
Thanks, everybody.
Thanks, guys.